All right, now that you know what it means to solve a system of equations and you understand what the solution to a system of equation is, we're going to look at a couple separate different ways to solve systems of equations outside of graphing. The reason being that graphing can be extremely inaccurate, especially if one or both of your variables involves a decimal or a fraction. So we're going to learn first substitution. It is just like it sounds. You substitute something in, you put it in place of something else. So we are going to take a quantity or an expression and put it in place or substitute it in for a variable. I want to point out I do have the formal definition here. You do not have to write the entire definition down, but I want to point out some important things from it. These would be good things for you to highlight or underline in your own notes. Solving by substitution. So if x or y is by itself, that is how I know it is going to be easiest to solve with this process. X or y is by itself, or x or y are easy to get by themselves. What that means is that x and y probably don't have a coefficient. There's going to be one case where a coefficient is okay, that we'll look at in example 3. But for the most part, we really don't want x or y to have a coefficient. It just makes things more difficult by involving fractions. It can be done, but if that's what we need to do, then there's probably an alternate method that would be easier than substitution. So these are the steps we're going to take. We're going to start by getting x or y alone. By getting it alone, that means get either x equals something or y equals something. So it's alone on one side of the equal sign. Sometimes you can skip step 1 if you're starting with an x or y by itself. You'll take what y is and plug it in for x. So kind of, or what x is and plug it in for x, y is and plug it in for y. So kind of let me show you what I mean by this. So I'm going to take a little side step on step 2. And if I had something like y equals 3x plus 4, and I told you that x was 2, could you solve that? Well, yeah, you would probably tell me you just put 2 in for x. Well, what are you doing? You're doing step 2. You're substituting what 2 is, or excuse me, what x is in for x, then giving me y equals 3 times 2 plus 4 using of order of operations to get 6 plus 4, or y equals 10. That's a very basic problem you all can do. You probably in your mind don't think of it as using something called substitution. You probably just think I'm plugging it in, or I'm doing it, or I'm solving it. But that's what you're doing. You're doing step 2. Now we're going to take it and make it a little bit more complex by, instead of plugging in a number, plugging in an expression, but that's what we're going to do. We'll solve the new equation we get for step 3, and then for step 4 we'll go back and find the other value, the other variable, since we are looking for a point. So looking at example 1, if I want to solve the system of equations, here's my first equation, here's my second one. I notice on my second equation, y is by itself here on the left. That's fantastic because I can skip right over step 1. Well, now that I know what y is, equal sign means is, so this is telling me y is 12 minus x. I'm going to go ahead, and before I do anything else, I'm going to say that this is equation 1, and this is equation 2. Okay. And now for step 2 here, because step 1 was done, I'm going to take what y is, I'm going to put it into the other equation. So in equation 2, I'm told that y is 12 minus x. So I'm going to put 12 minus x in for y on my other equation, giving me 2x, that stays the same, minus 3, that stays the same. Now, because I'm changing y, I'm substituting 12 minus x in for y, and I'm going to put it in parentheses because the whole amount, the 12, the subtract, and the x are all part of what y is. I'm going to put that in parentheses and put it in place of y. Then once again, I'm going to continue and say equals 6. So notice the only thing that changed is the y. Everything else remained the same. Now from here, it's just solving a basic linear equation. So I'll start by distributing my minus 3. 2x minus 36 plus 3x. I'll combine my like terms on the left. 5x minus 36 equals 6. I'll add 36 to both sides. That looks like a 136. My plus sign's kind of funky. Sorry about that. I get 5x equals 42. I divide both sides by 5, giving me x equals 42 over 5. I'm 100% okay with fractions, so I leave it as a fraction. But as you know, when you're solving a system of equations, you're solving for the point where these systems intersect. Well, x equals a number isn't a point. A point needs both an x and a y. So now that I know what x is, I'm going to go ahead and look at my step 4. I'm going to put that back into my equation. Either my original equation 1 or my original equation 2 up here. I'm going to go ahead and pick my original equation 2 since y is already by itself. Then I won't have to do any solving when I'm trying to figure out what y is, just simplifying with order of operations. I know that when I add or subtract with fractions, I have to have a common denominator. I cannot subtract 12 minus 42 over 5. So I'm going to go ahead and rewrite that as 12 over 1. My common denominator would be 5, so I'll multiply top and bottom by 5 here. Y equals 60 over 5 minus 42 over 5, which gives me 18 over 5. Now that I know what both x and y is, the only thing left to do is state my answer in the form of a point. Where do they intersect? Well, they intersect at the point with an x value of 42/5 and a y value of 18/5, and there is my answer. I would like to make sure that everyone watches videos 1 and 3. There is a video, example. I would like to make sure that everyone sees examples 1 and 3. There is an example 2, which I'll do right now. Then I will end this video. The next video will have example 3 only on it. So if you feel comfortable with this, and maybe this is jogging some stuff back from Algebra 1, or you feel like this makes sense, feel free to stop this video without watching example 2 and move on to the next video that has example 3. If you're still a little bit shaky, I would suggest you watch all 3 examples and now move on to example 2 here with me. Uh-oh. Where'd my screen go? Okay, I'm clearly having some technical difficulties here, so I'm going to go ahead and stop this and then go ahead and do an example 2 video and an example 3 video. So there'll be 3 videos posted.